this one, we're going to continue with exponential functions by looking at three tables, and we're going to determine which one would be considered exponential. Okay, so if you remember, a linear will increase by the same amount through addition or subtraction. So in linear, okay, they will increase. I would say add. Oops, sorry about that. I didn't make a mistake. Add or subtract. Okay, by the same amount. Okay, very important that we know that we're adding and subtracting, and these you're going to see all these with the y values. Okay, and then for exponential, okay, we're not going to be adding or subtracting, but we're going to be doing, think of like the other operations that you're familiar with. So if adding, subtracting out of the picture, the next really thing that you think of is we're going to be multiplying, okay, by the same amount. Okay, now when I say multiplying, okay, I'm a little hesitant to write division because you can actually do the same thing. Instead of dividing, I can actually multiply. So let me just show you what I mean. Okay, let's say I had the number 8. Okay, now I know that 8 divided by 2 is going to give you 4. But if I didn't want to use this division sign, what I could do is I can multiply, okay, by the reciprocal of this. So what is the reciprocal of 2? Well, 2 is there, okay? If you were to find a reciprocal, you put it over 1 to create a fraction, and then flip it. And now you have 8 times a half, or just say it backwards. What's half of 8? 4. Okay, so instead of dividing, we can actually just multiply everything by the reciprocal of the number that we were going to divide by. Okay, so this is the reciprocal of the number that we were going to divide by, and you get the same exact answer. Now, this has nothing to do with these three tables here, but it's good to understand that you don't always have to be dividing by something, especially because with exponential, we want to keep everything consistent about multiplying. So, which table represents exponential? We're gonna first look at all the x's. See how all the x's, they're going up and down by the same amount, right? 0 through 4. That's perfect. The only thing that's changing are these y's. So f of x is the same thing as y. And we're going to go through each one, okay? So to go from 1 to 3, how would you do that? Like immediately in your head, you're probably thinking, let's add 2. You're right. From 2 to 5, we're adding 2. From 5 to 8, we're adding 3. From 8 to 11, we are adding 3. Okay, so if you're looking at this, how would we categorize this? Would this be linear? Well, linear says that we're adding or subtracting by the same amount every time. Here we are adding by 2. We're adding by 2, but then we switch it and now we're adding by 3. So this is actually not linear. Okay, and how would you, is there a way that you can even multiply this? Right, if you would do like 1 times 3 would give you 3, but is 3 times 3 5? No. So then this is actually not exponential either. This is what we're going to call neither for now. So this is not an answer. Let's look at this one then, right? So from 1 to 4, we can add 3. If it was linear, we would have to add 3 to that, but we can immediately see that that's not going to work out. Okay, so let's try it by multiplying. 1 times 4 gives us 4. 4 times 4 is 16. Is 16 times 4 64? It is. And 64 times 4 is 256. This looks exponential. Okay, and of course, let's check the last one as well. So from 2 to 4 is add 2, right? 6 to 10, and we're adding 4. And then here we're adding back 2. This was almost linear, but that right there made it not linear at all. We cannot multiply by the same amount here, so this is going to be our only option.